Let's talk about logistic regression. Logistic regression is popular and it's relatively simple to describe. It works on binary classification tasks. After being trained on the training data, a logistic regression classifier will give the probability that an observation belongs to the positive class. Our introductory example of logistic regression, we're going to use a toy data set with just two features. By having two features, we have two dimensions. So we can visualize how this algorithm works more easily. Now let's talk about the big idea of logistic regression. What is actually going on? So the way that machine learning works in general for any algorithm is an iterative process. You try something, you fail, you analyze where the failures were, and then you adjust and you try again. You can visualize it as a cycle. And notice that failure is an important part of this cycle. It's just that we have to analyze how we failed so we can adjust and improve our attempt. Repeat this process, this cycle over and over again until we reach a stopping point. So how do we know when to stop? Either we run out of time, or we reach a point where we're convinced that we aren't going to improve, which means that we see diminishing returns for our efforts. So for logistic regression, first we decide when we want to stop. Begin with a line that attempts to separate the data into the classes. And we adjust the coefficients of that line so it better separates the data into the classes. Keep repeating step 2. There's a lot of code here, and I'm just going to explain the high-level ideas of what I'm illustrating. First, I'm going to use the make blobs command to try to create data that is easily separable. Then I am taking that data using sklearn's make blobs command, which is available in the sklearn datasets library, and I am going to cast it into a data frame for further analysis. I'm going to have two features, x and y, and I'm going to have a target called target. One of the best ways to visualize data like this is with a scatter plot where the hue is set as the target value. This will color code the points by what target value they take. Here is my data. You can see that it is mostly linearly separable, although not perfectly, but there should be a line that separates the data pretty well. Data set is a good candidate for logistic regression because it is linearly separable. Now I'm going to write functions that do several things, and unfortunately I haven't included enough details for someone else to really understand these functions, so that's not good. But please accept these as mystery boxes and we can move forward. What I want to illustrate is the process by which logistic regression works. Remember, this is an iterative process. It's going to do something over and over again. What I'm doing is I am stopping it artificially after a certain number of iterations so that we can see the best line it has found after that number of iterations. After one iteration, you see the dividing line here in red. And this line doesn't do a good job at all of separating the orange class from the blue class. Is that we just need to move the line down a bit. So on the next iteration, what the algorithm does is adjust the line slightly. It looks here like it adjusted the slope and the y-intercept. After 3 iterations, we see we need to adjust it again, and we do. Notice here it's adjusted the slope and the intercept quite a bit. Now this still is not a good line. It's tried 3 times, and we still have a pretty bad line. It's making small adjustments each time. Because it's allowed to iterate over and over and over again, small adjustments will work well enough. So after 4 iterations, after 5 iterations, notice this is still bad. 6 iterations, slightly better. 7 iterations, only slightly better. 8 iterations, a little bit better. Now we're starting to see some progress. 10 iterations, that's a pretty good line. But even with this data set that worked perfectly, it was pretty small. This took 10 iterations to find a decent line. After 10 iterations, the line pretty much looks the same. I think that you're not seeing much change past that point. The big idea that we want to emphasize is that this is an iterative process. Logistic regression is continually improving its deciding line, and it starts out with a pretty bad initial line and gradually improves it piece by piece. That's the big idea of how the logistic regression training algorithm works.